Good morning, students. You are welcome once again back to the online classes after the exams. We all hope that the half yearly exams have gone well. So let us move ahead with the portion that we had left, that we had to cover in order to complete the sound chapter. I'm sure you all remember we were taking up the sounds chapter. We had not finished the entire chapter. There were some characteristics of sound that are left, and let me first tell you the importance of this part that we are now going to cover. This comes ahead as a part or a portion of the sound chapter which is extremely important from the point of view of it being asked in the board examinations. Okay, so you will get questions, maybe as you can see in these graphical form, or also in terms of small theoretical questions where you may not necessarily score by learning things up, but you will have to apply a little bit of understanding of the concept and obviously your mind to it. Okay, so having understood the importance of this part of the sound that we are going to now deal with, I am sure, hopeful that you will pay enough attention, as much of attention as is required for this particular portion of the chapter. Okay, so now let us start with what is to be understood first. Characteristics of sound. So now in the very layman term, let me first explain the different ways in which you hear sounds. Okay, there are different kinds of sounds that you hear in your everyday life. One, for example, you can hear me speaking. Okay, so that is one sound that you can hear. You can also hear birds singing, you can hear your mother speaking, you can hear your father speaking, you can listen to a musical sound, you can listen to songs. You usually do listen to people who are speaking softly. Then there are people who usually speak very loudly. There are people who shout. Then there are people who have a melodious voice. Then you also hear some voices or some sounds which are very shrill or sharp in nature. Okay, they tend to make you uncomfortable. Okay, so these are all different examples of the different forms of sound that you hear in your everyday life. So while hearing them, obviously you can differentiate them or distinguish one sound from another. Okay, let's say for example, when I speak, although I am not in the frame, I am not in your view, but you know that this is a male person speaking, okay, or this is your physics teacher speaking. Suppose I move off and some other teacher, some female co-teacher or some male other co-teacher comes about and he or she starts to speak. You will immediately be able to guess the difference. Now, this guessing of difference is in terms of the perception of the sound, okay, the way the sound falls on your ear. Okay, so there are different characteristics that are responsible for this distinguishing feature. Okay, so these are some of the very important characteristics of sound that we are now going to start with. Okay, the first one, as you can see, it is very obvious. This word itself, loudness, is something that you are very familiar with. Okay, so loudness. Okay, how strong or how weak is a particular sound. Okay, suppose for example, a very basic example once again. Right now when I am speaking normally. Okay, I am speaking in a loud enough voice so that you can hear me easily. Okay, now sometimes the teachers do need to speak out loud or they have to shout. So like for example, I am shouting just now. So what is actually happening is, from the same mouth or from the same vocal cord, there is a more loud sound or there is a more strong sound that is coming out. Okay, so that explains the loudness of the sound. Okay, so loudness obviously of course depends upon a number of factors. These factors we will study later on in this lecture, but the very basic example of the term or the characteristic of loudness of sound, which is loudness, is the fact that you can distinguish a weaker sound from a stronger sound. Okay, so that's the difference. Now as you can see over here, this much what I have discussed till now, this is purely theoretical. Okay, this is purely based on the perception that our ears have. Okay, now have a look at how these sounds or how the loudness of sound can be represented on paper, okay, or in the graphical format, or in terms of the waveform. Okay, so because obviously you all know by now that sound, like light, is also a wave. Okay, so you can see I have drawn two different waves over here. You can see crest, trough, crest, and then it will go on like this. Similarly over here you see there is a crest, then there is a trough, then there is a crest, and there will be trough further on also. Okay, so both these are sound waves. Okay, now let us first analyze what is there on the y-axis and what is there on the x-axis. On the x-axis obviously you see there is time. So with the time, the sound wave is traveling. Both the sound waves are traveling. Okay, what is there on the y-axis? The y-axis says amplitude. By definition, from very basic classes you have understood the word amplitude. Amplitude means the maximum displacement from the mean position or the original position. So for the first sound wave, let's say for example this sound wave, this is the reference level or this is the original level. Okay, so this wave is actually going up how much? By how much? It is going from 0. If we suppose if we assume the reference level to be at 0, then this wave is going up from 0 up to a level of 5. Now the unit can be any unit you can choose. You can choose centimeter, millimeter, whatever. The fact is that this upper wave, sound wave, is going from 0 level up to 5 level when it is making a crest. Okay, so the maximum displacement from the mean position, this is the mean position, this is the maximum extreme position. So if you mark, this portion is what I am talking about. Okay, so this is your maximum displacement that is taking place, which is known as the amplitude. Okay, so similarly it is going down also. When it makes trough, it will go down by another 5 centimeter or millimeter, whatever. Okay, so you can see that it is having a displacement, maximum displacement of 5 units, the first wave. Now let us have a look at the second wave. The second wave, as you can see, it is going from the same original reference level of 0 up to only 1 unit this time. Okay, so you can see this is the amplitude or the maximum displacement from the mean position or the original position in case of the second wave. Okay, so although both these waves are sound waves, although both these waves are having the same nature, how do you know they have the same nature? Because you see, this is also a similar looking waveform, this is also a similar looking waveform. In fact, such waveforms, as you can see over here, I have drawn, such waveforms are known as sinusoidal waveforms. These are sine waves. Later on in maths classes, in higher classes, you will understand, you will probably learn about these names that are there. They are not so important over here, the names itself, but then I just wanted to tell you that the nature of these two sound waves is similar because they have the same waveform, which is known as the sinusoidal waveform. But what is the difference? The difference, obviously, as you saw just now over here, is that this second wave is a much softer wave or a feeble wave. Feeble means weak, or it is also known, it can also be called as less loud sound. So a sound wave which is moving from let's say in which the vibrations are taking place from an original status of 0 up to a status of 1 is going to be a comparatively lesser loud sound than the one which is going from 0 to 5. Okay, so this directly tells you that loudness of a sound is going to depend upon the amplitude. Okay, so if I put in a third wave also, in which the maximum displacement is 10, so then that will become the loudest waveform, okay, or the loudest sound. Understood? So the basic understanding of loudness, of the characteristic loudness, is how strong is the sound, okay, how much energy it is carrying, and that obviously depends upon the amplitude. More the amplitude of the sound wave, louder will be the sound. But this relationship is not exactly directly proportional. The exact relationship I'll tell you when we discuss the factors, the different factors. Okay, as you can see once again over here, loudness does not only depend upon amplitude, it depends upon a number of other factors. So all those factors we are going to discuss now. Okay, so I hope you have understood the basic difference between a lesser loud sound and a more loud sound, or a feeble sound and a strong sound, or a soft note and a loud note. Note is also one of the terms that we use to express the sound waves. Okay, so soft note and a loud note. Okay, so that is the first factor, or the prime factor, that we will keep in mind. Okay, so as far as loudness is concerned, this was a brief idea that I wanted to give. Now let us come to the second characteristic of sound, which is the pitch of the sound. Now this word, unlike the word loudness, is something that you do not hear in your everyday life. Okay, you may hear every day that people are speaking loudly, teachers telling you not to shout, not to talk loudly, things like those. Okay, but very rarely do you come across this word pitch every day in your life. Okay, so let us now understand what pitch is. Okay, now pitch, as you can see, there is only one factor which pitch depends on, and that factor is frequency. Let us first understand frequency. We already have a fair bit of an idea of frequency. Frequency, general definition is number of oscillations in 1 second, or number of vibrations in 1 second. Okay, so what is pitch? Pitch is that characteristic of sound which, with the help of which you can distinguish a shrill or a sharp sound from a coarse sound. Okay, now what is a sharp and a shrill sound? Suppose now let us take the example of a male person speaking and a female person speaking, or you might have sometimes heard in your homes when your father shouts at you or when your mother shouts at you, there will be a difference in terms of the shrillness of the sound. Shrillness means sharpness of the sound. The female voice is usually the more sharper one. Okay, the one which is more sharp, or the one which is more shrill, is said to be the high pitched sound. Now why is that sound more shrill? Because it has more frequency in it, or in other words, more frequency means more number of oscillations in 1 second. Okay, so if I tell you, let's say for example, okay, so let us have a look at this newly drawn diagram that I have included over here. Remember, we are discussing pitch. What is pitch? Pitch is a characteristic of sound. What characteristic? What does it do? It enables us to distinguish a shrill sound or a sharp sound from a coarse sound. Okay, तीखी आवाज and then मोटी आवाज. Okay, so you can understand in Hindi if you understand it better. These are the terms to be understood. Now, pitch depends upon what? Pitch depends upon frequency. Frequency means number of oscillations in 1 second. So I have taken up as an example for better understanding, I have taken two waves, wave 1 and wave 2. These are both sound waves. You can see both are sinusoidal waveforms. You can see the wave nature is the same. Okay, so in 5 seconds, you can see in a period of or in a duration of 5 seconds, how many oscillations are these two waves making, or how many oscillations are taking place in a given time duration. Let's say the time duration is 5 seconds. So you can easily say that if we talk about wave 2, one crest, one trough. So this is one oscillation. Okay, here it is making only one crest, the trough is not complete. So if in 5 seconds we take the time as 5 seconds, we can say that wave 2 is making 1.5 oscillations in 5 seconds. Okay, so in a period of 5 seconds, there are 1.5 oscillations, OSC oscillations, that are taking place in wave 2. Very easily you can have a look at wave 1 and tell me that in wave 1 there are many more oscillations that are taking place in the same time of 5 seconds. Okay, see, this is one oscillation, second oscillation, third oscillation, fourth oscillation, fifth oscillation, sixth oscillation, seventh oscillation. So there are 7 oscillations overall that are taking place in the first waveform. Okay, so in 5 seconds, now if you compare, wave 1 is giving you many more oscillations. More the number of oscillations, that means more is the frequency of the wave. So wave 1 over here is having a higher frequency. Okay, whereas wave 2 over here is having a low frequency when you compare these two. Okay, and as I have already said, pitch depends upon frequency. That means more the pitch, more the frequency, or the higher the frequency, more will be the pitch. And by saying more will be the pitch, what I mean is shriller will be the sound. Shrill is the word. Okay, so I will just write it over here. High frequency sound, or the shriller sound, or the sharper sound. Okay, so it will bite on your ear, it will appear very sharp to your ears. Okay, whereas this one, which is the low frequency sound, this can also be known as coarse sound, C-O-A-R-S-E, coarse sound. Okay, so these are the terms that you will have to remember. Okay, so higher frequency sound will be the more shriller sound, and this will be said to have a high pitch. Okay, so if somebody gives you these two figures and tells you without mentioning any of these things, if he only gives you this waveform and this time, this waveform and this time, and asks you which of these two waves has more pitch, so what will you look for? You will look for more frequency. Here is the more frequency, so higher the frequency, higher the pitch. Similarly, lower the frequency, lesser the pitch. So you can say here you have lesser pitch. Okay, less shrill sound. Okay, so that is as far as the word pitch goes. Okay, so this, by the way, you can measure frequency. You have already discussed frequency. Unit is hertz. SI unit is hertz. So frequency is something that you can measure, but pitch is not something that you can measure. Pitch is a sensation. It is the way of reception of the sound on your ears. If somebody is shouting in a very shrill sound, can you say that is shouting at this much shrill? No, you cannot allot a value or a unit to the pitch of the sound. It is just a sensation. Okay, it is a perception. Unlike frequency, frequency can be measured and the unit is per second or hertz. Okay, so that is the second characteristic of sound. I hope you are following. You might have to go through this particular lecture at least a couple of times and follow the book also for you all to understand the concept better. And please remember, this is an important topic of sound going on, so you must pay attention throughout. Okay, so now having discussed the two features, now please also remember that we have still not discussed all the factors on which loudness depends. So all those details are going to come up. Right now I am only giving you a basic idea of the three characteristics of sound, which is loudness, pitch. So these two we have discussed. Now we are going to move to the third characteristic of sound, which we call quality of the sound, or it is also known as timbre, T-I-M-B-R-E. Please remember, this timbre is not that lakdi wala timbre. Okay, the spelling also is different. The quality of the sound or the timbre of the sound, these are the same, different words meaning carrying the same meaning. Okay, so quality is also one of the characteristics of sound. Again, you may not hear this word timbre or quality of sound in your everyday life, but let me first explain what is quality. It depends upon the waveform. Till now I have only shown you the sinusoidal waveform, you see, but now we are going to move on to some different types or some different nature of waveforms. As you can see, this is a triangular looking waveform. Okay, now let us compare these two. One crest, one trough. One crest, one trough. So this is one oscillation, this is also one oscillation. Okay, but what is different? The difference is in terms of the nature in which the wave is progressing. Okay, so you see, this is a sinusoidal waveform, this is a triangular waveform. Similarly, this, as you can see, is a rectangular waveform. Okay, when you go to the higher classes and when you deal with the oscilloscopes and all, you will see, you will actually see these different kinds of waveforms on the screen or on the oscilloscope. So as of now, let us keep this fact in mind that all these can be sound waves. The only difference in these sound waves is the nature of waveform. See, this is the form in which the wave is moving, so that is known as waveform. Okay, this is different waveform, this is a different waveform, this is a different waveform, with having different names. Okay, so if somebody tells you what is the primary difference between these three sound waves, immediately you will say there is a difference in the quality, because quality is the only characteristic of sound which depends upon the waveform. The waveforms are different in all three, therefore the quality of these three sounds will be different. Okay, clear? So this was a basic idea of the different characteristics of sound that are there. Now I am going to move ahead to this particular detailed diagram that I have drawn, in which I have shown you 4 different waveforms, and there's a basic purpose why I have done this. So let us go ahead and see how much you have understood in terms of what I have explained. Okay, so now I want you all to pay good enough attention on this part that I am going to discuss, because this is the part that is sometimes directly asked in your board examinations, because this is actually a test of the concept understanding or the understanding of the concepts that we have learned in terms of the characteristics of the sound. Please remember the 3 things: loudness, pitch, and the quality of the sound. What does loudness depend upon? A number of factors. Primary one is amplitude. Okay, amplitude of the sound. Then what does pitch depend upon? It depends upon the frequency. More the frequency, sharper the sound or shriller the sound, and therefore it is called a high pitched sound. Then come to the third one, quality of the sound. What is the factor that decides quality of the waveform, quality of the sound? It is the waveform that decides the nature of the waveform. Okay, so now let us very quickly try and understand what is there in this particular diagram. You see, there are 4 different waves that I have shown: wave 1, wave 2, wave 3, and wave 4. Okay, what is there on the x-axis for all? Time, 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 time. Okay, so time in seconds is there on the x-axis, and on the y-axis for all waves you can see it is amplitude in centimeters. Okay, so that is the basic diagram representation that we have. Now there are numerous questions that can be formed based on this particular diagram that I have shown. So I will start with a very basic question first. Okay, please remember, this is actually a test of whether you have understood what I explained previously in this lecture. Okay, keep in mind loudness, keep in mind pitch, keep in mind quality. Okay, so my first question is, what is the similarity that you see? Please listen carefully. What is the similarity that you see or you find in the first two waveforms, wave 1 and wave 2? I am asking about the similarity. So you will easily, very quickly, you will say that the nature of waveform is similar. This is also sinusoidal waveform. This is also a sinusoidal waveform. Okay, so the nature of waveform is same in wave 1 and wave 2. So my next question, can I say that wave 1 and wave 2 have the same quality? Yes, I can easily say that wave 1 and wave 2 have the same quality. Why? Because quality only depends upon the nature of waveform. The waveform nature is same here in these two cases. In fact, in the third wave also you see that it is sinusoidal. The only fact is that it is unable to complete with the progression of time. It will eventually complete its own trough also. So you can easily say that wave 1, wave 2 and wave 3, they are having the same nature of waveform. Therefore, wave 1, wave 2, wave 3 have the same quality. Clear enough? Now, the second aspect. My next question would be, can you identify any two waveforms out of these four? Can you identify any two waveforms that have different quality? Different quality. Very easy. Wave 4 you can see is a triangular waveform pattern. It is in triangular, it is making crests and troughs in triangular form. Okay, whereas the first three, again as I mentioned, they are all these three are making sinusoidal waveforms. So the first three are different from the fourth one in terms of the quality. Easy enough? Now the third aspect. Let us have a look at the first and the fourth wave. Okay, let us have a look at the first wave and the fourth wave. Okay, forget about the central two waveforms. Only concentrate on the first one and the last one. One difference we have already discussed. This is sinusoidal, this is triangular. So the qualities of first and fourth waves are different. Can you tell me any other difference in wave 1 and wave 4 apart from the quality? So immediately you should have a look at the amplitude of the first wave and the amplitude of the fourth wave. The first wave is going up to a maximum value of 2, whereas the units are always, you can assume any unit. Here it is centimeters. So from 0 to 2 centimeters. That means first wave has an amplitude of 2 centimeters. The last wave or the fourth wave has an amplitude of 8 centimeters. So isn't the amplitude different? Yes, the amplitude is much more in wave 4. Therefore wave 4 will be much louder than the first wave. Okay, because again you have to remember loudness. I told you loudness, one factor that loudness depends upon is the amplitude of the sound wave. So here the amplitude is much more, in fact 4 times more in comparison to the first wave. Therefore wave 4 will be much louder and stronger than wave 1. Okay, so that's the second difference that you have found out. Okay, so this is quite an interesting study that you can actually do it yourself also. But since we are discussing this first time here, so I would like to discuss the different aspects in which the questions can be formed. Okay, so now once again, let us have a question on pitch. Let me frame the question first. Out of these 4 waves, can you tell me or can you identify any 2 waves that have the same pitch? Listen to the question once again. Look at these 4 waveforms and tell me any 2 waveforms which have the same pitch. So remember, go back in the lecture. What was pitch and what did it depend upon? Pitch depends only on frequency. Okay, so I am asking you, which of these 4 waveforms have the same pitch? So any 2 waveforms which have the same frequency will have the same pitch. Okay, so look for any 2 waves that are doing the same number of oscillations in a given time period. Okay, so if you see, if I take up this entire time duration from 0 up to this point in first wave and in the last wave, you see from 0 up to this, these are all parallel lines that I have drawn. Okay, so if I take a time duration from 0 up to this point for this wave and from 0 up to this point for the last wave, how many oscillations do you see in each of these? You see 1.5 oscillations here, and you see 1.5 oscillation here also. So in a given time period, this wave as well as this wave, so if this time period is let's say for example from here up to here and from here up to here, so how many oscillations are taking place in wave 1? 1.5 dead oscillations, 1.5 oscillations. You must know that this crest and this trough together makes 1 oscillation. Similarly, this crest and this trough makes 1 oscillation. So this is only half oscillation. This is only half oscillation. So 1.5 oscillations here, 1.5 oscillations here. So you can easily say that these 2 waves, wave 1 and wave 4, have the same frequency. So when they have the same frequency, they will have the same pitch. Okay, so what was the question? The question was, identify any 2 waves which have the same pitch. So wave 1 and wave 4 have the same pitch. Okay, let me reverse the question. Identify any 2 waves which have different pitch. Very easy. This one and this one. Different pitch. Remember, different pitch. Pitch depends upon frequency. So different frequency will mean different pitch. You can see in this time, this much time, first wave was only making 1.5 oscillations. Here it is making 1, 2, 3 oscillations. So wave 2 is making 3 oscillations total, and this is making 1.5 oscillations only. So different frequencies, therefore different pitch. So wave 1 and wave 2 have different pitch. Okay. Similarly, you can also say that wave 2 and wave 4 have different pitch. Okay. So there are different combinations that get formed. So you must be able to identify concept based questions like these and the way in which they are to be solved. Okay. Now very quickly, a quick conceptual question here. Out of these 4 waves, which is the most feeble wave? Feeble means weak, kamzor, in terms of the loudness obviously. So you will have a look at the lowest amplitude. This wave goes up to 8, this wave goes up to 5, these 2 go up to only 2. So therefore these waves, wave 1 and wave 2, are the softest waves or the softest notes or the less loud notes or the feeble sound waves. Okay, which is the strongest sound wave? Wave 4 is the strongest sound wave because it is the loudest, because its amplitude is the loudest. Okay, so this is what I basically wanted you all to understand properly. Okay, now talking in terms of quality, we have already discussed quality. Now in terms of the musical instruments, let me give you a brief idea, although that is not in your course. But then even if you close your eyes and you listen to a tabla, okay, and on the other hand you listen to a sarangi or listen to a violin, so do you feel it necessary to open your eyes to tell the difference between the two sounds? Obviously not. You can close your eyes, you can keep your eyes closed, and you can easily distinguish the sound of a tabla from a sarangi or from a flute or so on and so forth. Okay, so that means, what is that distinguishing feature? Are you calculating something? No, you are not calculating anything. You are simply hearing those sounds and you are able to distinguish them. How so? Because of the quality of the sound that they are producing. Okay, so that is the practical aspect of the word quality. Now let us quickly come to some minor details that I wanted to brief you about. Have a look first over here, or rather let us have a look first over here. Since we have discussed loudness can be measured. You can see, if something can be measured, it has to have a unit of loudness, which is the SI unit. It is phon, PHON, all in small letters. Phon is the unit of loudness, although you will see dB, decibel, okay, small d and capital B, it stands for decibels. Okay, this do not get confused between dB and phon as the unit of loudness. Phon is the unit of loudness, whereas dB is actually used to represent the level of loudness of sound. So for example, you will say a 20 dB sound, then a 50 dB sound, then an 80 dB sound, and then a 250 dB sound. So what is the difference between all these sounds? The levels of loudness are different. Okay, so this is the loudest sound. In fact, this goes into the range of noise. It disturbs your senses. It can create headache. Okay, so the normal conversation usually takes up around 60 to 80 dB. Okay, this is around about the normal level in which we usually discuss things about. Okay, so noise and the other things have been removed from your course, so they are not that important. The musical sound and all those, they are not a part of your course. Reduced syllabus I am talking about. Okay, but since we are discussing loudness, we have loudness in our course, therefore we must know the SI unit of loudness, that is phon, and then dB is used to represent the level of loudness of the sound. Now coming back to a very different aspect altogether over here. For human ear, the sensitivity is maximum at 1000 Hz or 1 kilohertz. What does this statement mean? Take half a minute, read this particular statement and try to comprehend what it is trying to tell you. For human ears, that means for our ears, the sensitivity means how quick we are in terms of our response to hear a particular sound. Okay, so that is maximum when the sound frequency is 1000 Hz or 1 kilohertz. I'm sure you have still not understood it properly. Let us take an example over here. This will clear everything. 20 dB sound at 500 Hz and 20 dB sound at 1 kilohertz. Let me first give you the difference between these two sounds. What is the similarity between these two sounds? The level of loudness is same. This sound is also 20 dB sound, this sound is also 20 dB sound. So that's the similarity. Both are equally loud. What is the difference in these two sounds? The difference is in terms of the frequency. This sound is coming at a frequency of 500 Hz, whereas this sound is coming at a frequency of 1000 Hz or 1 kilohertz. Okay, so both these sounds are equally loud, but their frequencies are different. If both these sounds fall on your ear will perceive or sense this sound more quickly and more responsively, because our human ears are designed in a way that their sensitivity is maximum at this particular frequency. So it is this sound that your ear will perceive and sense very rapidly and quickly without any problems. Okay, got that? So that is the difference between the frequency aspect and the loudness aspect. Now we are going to go to the, as promised, the different factors that the loudness depends upon. Okay, so here are the different factors. The first one, obviously, if you remember, we have already discussed it. Loudness depends, this is the sign of proportionality. So loudness depends upon amplitude. Till now we had discussed that more the amplitude, louder the sound. Now this is the exact relationship. That means loudness is proportional, directly proportional to the square of the amplitude. That means if you increase the amplitude 2 times, the loudness will become 4 times, because there is a power of 2. Okay, so if you increase the amplitude of a sound 3 times, the loudness will become 9 times, because 3 square becomes 9. Have you got the basic difference? Okay. That was the primary factor, the first factor. Then second, loudness is inversely related to the distance, square of the distance. Now what distance is this distance? Suppose you are standing close to a tabla. Somebody is producing a sound on the tabla and you are standing nearby. Okay. One of your friends is standing at 20 meters away from the same tabla. You are one person listening to the tabla and your friend is another person listening to the same tabla. Okay, you are standing closer to the tabla, your friend is standing far away, 20 meters away. Who do you think, which one of you two will hear the tabla sound more loudly? Obviously you. So with distance, with increasing distance, the loudness drops. Okay, so that same tabla which is being which is creating the sound, to the person who is standing far away, the loudness will drop. That means inverse relationship, ulta relationship. Distance, if the distance increases, the loudness will drop. Okay, again please remember the relationship is in terms of a square. So if the distance between the source of sound, which is tabla, and the person who is hearing the sound, which is your friend, if the distance between these two is doubled, then the loudness will fall by 4 times, because there is a square. Okay, so understood the difference? Then coming on to the third one, loudness obviously depends upon the surface area of the vibrating source. You take a smaller tabla and then you take a nagara, a bigger one. Okay, so you bang on them, both of them. Obviously the one that has more surface area will create more loud sound. It will be heard at far away distance. Okay, then loudness is also directly proportional to the density of the medium. Medium means the medium in which the sound will travel. Okay, so more dense the medium, louder will be the sound. And the last one obviously is loudness is directly proportional to the presence of resonating bodies. Resonance process we have already done. Resonance means resonating bodies are those bodies because of the presence of which you tend to have a higher amplitude sound created. So higher amplitude sound will always result in a louder sound. Okay, so from numerical point of view, these 2 factors are important. Theoretically, obviously, all these 4 factors are, or 5 factors are important. Please remember, amplitude and loudness, they are directly related. That means one thing increases, the other also increases, but not in the linear fashion, in the square fashion. Okay, so if amplitude becomes double, loudness becomes 4 times. Then distance becomes double, loudness drops by 4 times. Okay, so that is what we have. Now coming on to pitch very quickly, this is something that we have already discussed. Pitch is directly related to the frequency. If frequency increases, pitch also increases. So more F value will give you a higher pitch sound, which is also known as the shrill sound. Less frequency value will give you a less pitched sound, or a coarse sound, or a mota sound, as you say in Hindi. Okay, Now let us discuss. Now we have basically discussed everything that is there in your course in terms of the sound chapter. There is one numerical that I want to discuss with you all. After that I'll give you some questions in terms of the practice for the numerical that you'll have to do. Okay, let me first discuss one numerical over here. Okay, so here is the question that I want to discuss with you all. Two waves, so obviously we are talking about the sound waves here. Two waves have amplitudes in the ratio 1:3. So A1 is to A2 is 1/3 or 1:3. So there are two ways obviously of writing it. A1 is to A2 you can say is 1:3, and the same thing can be represented like this. Okay, so the ratio of their amplitudes is 1:3. What do they want? They want the ratio of their loudness. Okay, so for that you must know the relationship between the loudness and the amplitude, and that is exactly what we have discussed just before this. So we have discussed that loudness is directly proportional to the square of the amplitude. Please remember this relationship. Okay, so that means this translates into L1 upon L2 will be equal to A1 upon A2 square. Okay, so this is the formula that we are going to use for such questions. Okay, how does this formula come? This formula is a translation of this concept that we have. Loudness is directly proportional to the square of the amplitude. That was the first factor that we discussed just now. Okay, so if you are talking about two waves, this L will become L1 for first wave, L2 for the second wave. This is the relationship. Now you can easily use this formula. L1 upon L2 is equal to A1 upon A2 value is already given 1/3. So that becomes 1/3. And please remember there is a square. So this becomes 1/9. That means first answer will be L1 is to L2 is 1:9. That is your answer for the first part of the question. So that is the first part. What is the second part? The ratio of their pitch. Okay, so the first question that should come to your mind is, does pitch depend upon the amplitude? No, pitch depends only on the frequency, and they have not mentioned any difference of frequency. So that means P1 upon P2 will remain 1:1. Their pitch will remain same. These two waves will have the same pitch because amplitude difference does not have any effect on the pitch. The only factor that affects pitch is the frequency. So had they said in the question that the frequency of two waves are in the ratio 1:2, then the pitch also would have been in the ratio 1:2. Okay, so I hope now you have understood the entire concept. This was just one way of showing you how to solve such questions. These are very simple questions, only requires the remembrance of the relationships. Okay, so once you have gone through this particular lecture at least 2 times, please go through this 2 times. This is very important, but quite easy also to understand, but you must spend some time, and then I'll give you a small assignment based on this. Next chapter that will be coming up will be calorimetry. Okay, please remember these were the things that are a part of your reduced syllabus. So do not concern yourself with each and everything that is there in the book. Okay, this is what is there in as a part of your syllabus. Thank you.